here is the server, and you see we are opening our socket. We have, but be sure that every computer connected to the network has a unique IP address. Okay, this is like an ID number that you have. Okay, server opens socket, binds it, and listens it. Okay, and while it is listening, it is waiting the connection or request coming from client. So what happens? Client opens the socket. Socket means it opens a port. Okay, and it is being a node. Okay, opens the socket and tries to connect to the server. And when the request comes from client to the server, server accepts the connection. Okay, and then when the connection is established, client sends a message, data, okay, to the server. Server receives it, and in this state diagram, what happened? We send a message back to the client, like an acknowledgement, okay? And the message returns back to the client, and then the sockets will be closed, okay? This is very basic state diagram for server and client model. Just I want you to understand the idea here. Open socket, bind it, listens it, and accept the connection, okay? Accepts the connection, and it is entering into wait status and waits the client to make a request for connection. And when it comes, we will have a connection between client and server. Okay. And after that, we will have, we deliver messages to each other. And then when the message delivering is finished, the sockets will be closed. This is the idea of, general idea of, server and client model to communicate over sockets. Any question? Okay. What about synchronous client socket and synchronous server socket? Okay. This is the first type of code example. Okay, you can create synchronous sockets. What I mean with that? I will solve an exercise with this, but before I do that, you should know that what happens on client side and what happens on server side. In the exercise that I'm going to solve, okay, we will create a client that connects to a server. Okay, the client is built with a synchronous socket, so execution of the client application is suspended until the server returns a response. Okay. On the server side, we'll create a server that receives connection requests from clients, and the server will be built with a synchronous socket. So execution of the server application is suspended until the connection happens from a client. The application receives a string from the client, displays a string on the console, and then replies back to the client. And the string, this is important, the string coming from the client must contain the string EOF. This will be a character combination for me to signal that it is the end of the message, okay? Now I will solve an exercise, but here the very important part is it will be synchronous. It means that server or client will suspend until connection is until the connection is established or server returns a response. Okay, this is the idea here. It will be in this exercise. Okay. Okay, then let's start to our exercise and let's talk on that. On the left side, it's client. On the right side, it's server. Okay. First of all, I need to add some namespaces in order to be able to use some, some classes for my socket programming. So, other than system, I need to add system.net Okay. And of course, I will need system dot net dot sockets. Okay, and system dot text. Okay, these are my namespace that I need here. Okay, but you know, if we look to the structure, let's start from the server side, okay? Because based on the state diagram, it will be more understandable for you. So I'm moving to server side and write a code for each step here: socket, bind, listen, and accept till wait connection mode. Okay. Okay. Then here I will use this. I will use the same namespaces. So I need to write system.net and using system.net.sockets and using system.text. Okay. Now, after I do this, here for the main, I don't need arguments. Okay, I'm deleting this part. I'm deleting hello world. Okay. Okay. And let me be sure everything runs properly. Okay, that's good. Now, first of all, I'm going to create a data buffer, okay? I will use it for incoming data. So I will say byte. I will say bytes is equal to new bytes and 1024 bytes, okay? Okay. This I will use it to, you know, for incoming data. When the data comes, I will put it here. Then the next step should be to establish the local endpoint for the socket. Okay. Then I need to use IP host entry. Okay. I'm going to give a name here, IP host info, let's say. Okay, I'm giving this name is equal to domain name server dot get host entry and DNS dot get host name. Okay. Let me decrease the zoom size because I want you to see the whole code. Okay. Now, as you see, we need a system.net namespace in order to be able to write this code for a IP host entry. Okay. And what I'm doing here, after I do this, I will be able to get the IP address. Okay. Actually, now I know IP address. I can directly use it. But I am assuming that this server is on another computer, and I will run my code. So I don't know the IP number while I'm writing the code. So I'm writing these statements to get the IP of the server at the moment. Okay. And the second advantage is when the admin changes IP address of the server, this will automatically be changed. I mean, my code will run again. Okay. So for IP address, okay, is equal to I will use IP host info dot address list 0. Okay. This will give me an IP address in hexadecimal code. If you say 1, okay, you can get the IP address directly. If you say 0, you will get it in hexadecimal code. So here, I will use IP host that I declared here. Okay, I created this object here. Sorry, the IP host, that's a variable here. Then I will use that variable with the property of address list and to get the IP address. Now, at the moment, my IP address variable contains, IP address of the server. And here, after I know, and if you know the IP address and you don't want to, struggle with these statements, you can directly use the IP address. Okay, no problem. But here I'm showing you to get the IP address automatically in your code. Anyway, now I know my IP address. After I know my IP address, it's okay for me to, create the socket with a port number on this IP. So I'm going to say IP endpoint local endpoint is equal to new IP endpoint. Now I'm going to write my IP address. So IP address, comma, what will be my socket number? Sorry, port number. I'm saying 11,000. Okay. Now, on this IP address, this port number will be declared to local EP. Okay, now I'm going to create TCP IP socket. Okay, I will use TCP IP protocol here. I will say socket listener is equal to new socket, and for my IP address, I will use address family, comma, socket type will be stream, okay, and protocol type will be TCP. Okay. 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 Here, what happened? What I did, I'm trying to create TCP IP socket. Okay, TCP IP, it's a protocol, and here I don't want to, talk more detail here, but I used my IP address family. This will be my first parameter. Okay, and socket type stream, and protocol type is TCP. And here I created, I initialized a new instance of the socket. Okay, I named it listener, and after that I will say listener dot bind. Now I'm ready to do that. Local endpoint. Okay, and local endpoint is my IP address and the port number, so I bind it. And I say listener.listen. I'm starting to listen it. Okay, I'm saying 10. This listen, as it is seen in the comment part, places a socket in a listening state. Okay, and then string data, and here I'm going to create an infinite loop while true. Okay, I'm going to create an infinite loop. Okay, because my server will run always. and many clients will be able to make requests to my server. So on the server side, I'm going to create an infinite loop because I will always listen. Okay. And here, but before this, let me say data is equal to null. Okay. Now, sorry. Sorry, let's don't do this here. Let me create it. Let me declare it first. String data. Okay. In the infinite loop, first of all, I'm going to say socket handler is equal to listener dot accept. Now, when I say this, server will start waiting. Program is suspended while waiting for an incoming connection. So I will be here. Okay, I will wait for connection. Okay, I am in this state. Wait for connection. Okay, here. Okay, let me stop here. I will move back to my client and write the code for connecting to the server. Okay, I will switch between client and server, then you will understand easily what I am doing, which part for what. Now, I'm going back to my client. And here, okay, no need for arguments, no need for this. Okay. Here, first of all, I need also to declare a variable for incoming data. So I will also write the same thing here. Bytes is equal to new byte 1024 bytes. Okay. After that, I'm going to establish the remote endpoint for the socket. Okay. Again, I will use the same port number that I used on server. I must do that, of course, otherwise they can communicate. But before I do this on client side, I need to know IP address. Okay, I need to know IP address. So here I'm saying IP host entry. I'm doing the same thing here. IP host info is equal to host info is equal to DNS dot get host entry and DNS dot get host name, and then IP address is equal to IP host point IP host info dot address list 0. Okay, and then IP endpoint is equal to remote. Now this is client side because I will say remote. Here I said local IP. Here I will say remote. This is the name I'm giving. Okay. Equal to new IP endpoint, IP address, port number, which is 11,000. Okay, I am using the same. This IP address is the client's IP address, and then this is the port number. Okay. But friends, now why I'm doing this? Actually, this IP address is belong to server IP address. This IP must be server's IP address because I'm going to connect this server. But the problem is I am using a single computer now, so my server and my client is the same computer. Okay, this is why I wrote the same statements here. But if you are developing a project that your server is on another computer, of course you will not write this part, because this will give you the IP address of the computer that your program is running. So if I know the client's IP address here, it has no any meaning, because I will use this to connect to the server. I need to know the IP address of the server. Okay? But now this is an exercise, and this is why I am using these statements to get the IP address of my computer, because server and client are running on the same computer. Please be aware of this, okay? If you are developing a project that your server is not local or is not on the same computer with your client, of course you don't need to write this. Don't write this. You will use the IP address of the server here. Okay? Don't forget this. Okay. Then I'm going to create TCP IP socket. Socket sender is equal to new socket IP address dot address family, comma, socket type will be stream. These are the constants. Protocol type, but of course based on the project you can change them, but now I'm going to use these constants, stream and TCP. Okay. And then I am ready to connect to the remote endpoint, to the server. So what I'm going to do, if we look to the diagram, I'm here, I'm ready. I need to connect to the server. So here I'm saying sender dot connect where to my remote EP. Okay. When I say this, it will try to connect to the server. Okay, connection to the server. And here, when an incoming connection comes, okay, so we are in listening mode, we are waiting, and we are in accept actually status, so I can accept the connection request. Then here I will say data is equal to null on the server side, and I will have another infinite loop here. Okay, infinite loop here, and I will try to get the message from client because when it comes to here, to this statement, it means that a connection request came from the client, and now server is ready to, and connection is established, and server is ready to receive message. So here I'm going to get this message, okay? And I will say integer bytes record is equal to handler receive bytes, and data class equal encoding. It will be in ASCII code, so I will say ASCII get string to bytes starting from 0, and it will be in bytes starting from 0, and it will be recorded into bytes record. Okay, and bytes record will have my message. So what I'm going to do, I will here I need to check when the message is finished, because in every byte I'm adding it into data. I'm adding it into data. When new byte comes, I'm adding it into data. But how this loop will finish? This loop will finish when I get as I said before, EOF word from the client. I will understand that when I get EOF, I will understand that, okay, the message is finished. Okay, the message is finished. So here I'm saying if, okay, I will continue here, okay? Let me put stars. I will continue from here. I'm going back to client. I will send message here, then you will understand what I'm going to do. Okay, I'm going back to client. Let me send the message to the server. After connection is established, I will say byte message. This is the message that I'm going to send. Encoding, I need to encode it, encoding ASCII and get bytes of it. Okay, I'm encoding the data string into a byte array. Okay, I'm encoding the data string into a byte array. So that is my message. Okay, actually, if it is a Windows application, you can use a text box and you can get the message from there. Okay, but now it's console application. Again, I can read it from user, but I will type it as constant. Okay, this is a message. Okay, but at the end of message, I will say EOF. Okay, I will use this less than EOF greater than symbol to just mention that this is the end of my message. Okay, and okay, then I'm going to send the data through the socket. So integer byte send is equal to sender dot send my message. Okay, now I am sending my message by using this. Okay, but a value will return back, so I'm keeping it in byte send as integer. Okay, if you don't keep it here, doesn't matter, but why we are using is for acknowledging something, but I don't want to talk much detail about that, but we are using it to acknowledge, so it's better to keep the return value into a variable, but in this exercise I will not use it. Okay, anyway, here I sent the message. This is the end of my message. So here, okay, I'm going back to server. I need to understand that, okay, it's the end of the message and quit from this infinite loop. Okay, and here I'm saying if data index of, you can use this string method, and when it detects our special code less than EOF greater than, okay, and when it finds it, saying this, when a value returns back from index of method and it is less, if a value returns from index of method is greater than -1, it means that it found this code, this string in data string. So it means that the message is finished and I can quit from this loop. And I will say break here. Okay. And what happens? I will quit from while loop because I got the message. And after I got the message, let me display it on the screen. I will say console write line text is received. Text is received. Okay. And like C language, I can do this. Let's say the text received is this. Okay, I will display the message or the text or the message. Let's say the message received is this. Okay, I will display it here. It will show the message. And after I do this, okay, it's okay, then I got the message and this is the message. Then what happens? I'm going to reply to the client. Okay, I will acknowledge to the client that, okay, I got the message. Everything fine. And here I will say byte message equal to, I'm using encoding, and we'll encode it into ASCII code. Bytes. Okay, what is my string? The message is received. Okay, this will be my message to the client, and then I'm going to send it. I will say handler send my message to the client, and then shut down socket shutdown. This disables a socket for both sending and receiving. Okay, and this should be both. And then I'm closing handler. Okay, I send the message back to the client and close everything, and then it will go back to the beginning of the while loop here and starts to wait another connection comes from a client and to accept it. Okay, and I'm going back to my client because server is replied to the client. I'm going back to client, and here I need to receive the response from the server. I will say integer bytes recorded, bytes record, let's say, is equal to sender receive bytes. Okay, and after I get it, I need to display it to on the client side that the message coming from acknowledgement message is coming from. But friends, this byte send is different. Okay, when I send the message, I'm getting a value. Okay, I will not use it here, but I'm getting a value that I sent the message. Okay, when I sent the message, but this is different. This sending a message from server to client. This is the acknowledgement message that I sent. Okay, from server to client. This is different. Here I'm getting the message from the server. This is the acknowledgement message from the server, but this is not acknowledgement if something is happened or not, or the command is run properly or not, like byte send. Okay, this is different. So here, after I get the message replied, then I need to display it to the client. So I will say console write line reply, or let's say that maybe response. What is the response? Response is encoding ASCII get string bytes starting from 0, and it is bytes record. Okay. Okay. And I displayed it, and after that I need to release the socket. So I'm saying sender shutdown both. Okay. For sending and receiving, I'm shutting down the socket, and then I'm closing the sender. And after that, it's okay, I think. The client is finished. Okay. Yes. Everything seems good. Now, let me run it and see what happens. But first of all, I need to run server. Okay, now server is running, and it is in this status. It is here. It waits, connection coming from client. Okay, so I'm going back to client and I'm running the client, and we have some errors. Let me find that. Let's continue. No, where's that? Sorry. Okay. And I'm running client. Okay. Then what happened here? The message is received. It means that server get the message from the client. It displayed here the message received. This is a message, okay. And then replied back to the client, and client displayed the message is received. Okay. Let me, and here the diagram, state diagram is worked properly, but let me write some informative messages, and I will make it more understandable for you. The first thing here, the message that is sending from the message is received is coming from server. So here I can say server replied the following message. This is the first thing that I want to do. Second thing, I can, after I run connect method here, let me say console write line socket connected to the socket connected, let's say. I will understand that it will be connected, and then I will send a message. Socket connected, and here after that console write line message, the message sent. But it will be logical to write it here, because after this statement I sent the message. Okay, then on the server side, I can write here, and we can understand that we are in, let's say, waiting for a connection. So when I come here, I should say console write line waiting for a connection. Okay. Then I will see this message on the screen because I will be in waiting for connection status. So here I will say a message that waiting for a connection, and I will understand that I am in that position. And I think you can understand with this format. Okay, I'm running my server again. Okay, as you see, waiting for a connection. I am here. I'm waiting. Okay. Okay. Then I'm running my client. Errors. No. I'm running the client. Okay. What happened here? Socket connected. Okay. The message sent, and then the message received. This is a message. It came from the client. Then I replied back, and then client says that server replied to the following message. Replied to the following message. The message is received. Okay. You see, the client and server is communicated. Now, I'm not closing socket. I'm not closing server. I'm closing client because my server is still in waiting for a connection. It waits for another connection. And let me run my client again. I'm running it. And you see, it connected again as a new client. Sent the message, get the replied message, and finished. And as you see on the server side, the message received, this is a message and waiting for connection. It waits another connection. And I'm going back to client, and here the message that I sent, I'm changing it. This is a message, but I'm going to send the message CMP 342. Okay. I'm going to send this one to the server, and I'm like a new client, like another client. I'm running the client application, and again, I socket connected, message sent, and server replied. Okay, and here, when I go back to my server, you will see that new message CMP 342. Okay, this is how we can let two applications to communicate over sockets. Okay, but be careful. This is, synchronous connection. Okay, actually, the first thing that I can say, you can make some modification on these applications. You can update the client in order to be able to send more than one separate message from the client. Okay. You can update the server in order to be able to stop by the user. I mean, not stop, and because how it will stop. Okay, that is another issue. You can make some modifications on this exercise to improve yourself. And the second thing. In this example, both the client and server are run on the same computer, I told you. Okay. When the client is on another computer, the client should use the server's IP address instead of using local IP address. Okay, be careful about that, I warned you. And in this example, we used Transmission Control Protocol, TCP. There is another protocol, UDP, User Datagram Protocol. Okay, and other protocols are also available. Okay, you can try other protocols, but the different protocols have different, theories, different philosophies at the background. Both TCP and UDP are protocols used for sending bits of data you can call it packets, over the internet. Both protocols built on top of the IP protocol. In other words, whether you are sending a packet via TCP or UDP, that packet is sent to an IP address. Okay, these are the things that I can say about TCP and UDP. Protocols, actually, I can give you a few differences between TCP and UDP. For example, TCP is a connection-oriented protocol. UDP is connectionless protocol. Because of that, when you write your statements, there will be differences. TCP is slower, UDP is faster. But in UDP, error recovery is not attempted. Header size is 8 bytes in UDP, 20 bytes in TCP. And TCP is reliable as it guarantees delivery of data to the destination router. UDP, on the UDP side, the delivery of data to the destination can't be guaranteed. Okay, these are a few differences, but you can find detailed differences on the lecture slides. And another thing is, this solution that I gave you is synchronous solution. What I said, what is synchronous? Execution of the client application is suspended while the server returns a response. And server application is suspended while it waits for a connection from a client. This is synchronous solution. If you apply asynchronous solution, then the client application is not suspended while the server returns a response, and server application, execution of the server application is not suspended while it waits for a connection from a client. This is the difference of using asynchronous solution. And actually, I will not solve it here, but I gave you some links in the lecture notes. If you are interested with the topic, then you can check those links and see how we can develop asynchronous solution for our client-server communication over socket. Okay? Okay, friends. I think it's okay about socket programming.